I'm going to use an example with Gouldian finches to talk about how and why you might create a Punnett square and what information you can derive from this, and also how to use probability to understand and get the same information that you would get from a Punnett square. So in this example, we're imagining that you're a finch breeder and you need to get as many purple-breasted Gouldian finches that you possibly can, and your market share is even better if you get purple-breasted finches that have a white beak. And that's because people that are bird lovers will pay more for these particular birds. So you're going to use a little bit of the genetic information to try to maximize your mating. So we start with the knowledge that breast color, the purple breast color, is a recessive trait, and that's little r. If you have the dominant allele, which is capital R, then you're going to have a blue breast. The white beak is a dominant trait, so it's capital B. If you have the recessive trait, the recessive allele, you'll have a brown beak. So let's look at the parents, or an example using two parents. Our female has the genotype capital R, little r, capital B, and the male is a purple finch that has a white beak. It has the two recessive alleles for breast color. So this is a blue-breasted, white beak female crossing with a purple-breasted male with a white beak. Before we start to make the Punnett square, we need to know how big the Punnett square should be. And the way that we determine that is by looking at the number of alleles. In this case, we have two different alleles, the breast color and the beak color. And of course, there are two of each, so that's going to be 2 squared. If we had 3 different traits that we were looking at, we would look at a number that would be 2 to the 3rd power. So this number is the number of different traits that you're looking at, and it's always going to be 2 to the x power, meaning that x is the number of traits you're looking at. So that, of course, is 4, so we're going to have a Punnett square that is a 4 by 4 grid. So let's fill in that grid now. And the first thing that we're going to do is we're going to start with the allele number 1 in the female parent, and that's up here. And so we're going to put the capital R in. We're going to look at the first position of the second allele is going to be B. And then we're going to pair that R with the other B. I'd call it 1 and 2 if you need to keep track of them. So R, and now we're looking at B. We'll call it number 2. Next, we're going to look at the lowercase, the second allele, and that's our lowercase r, and we're going to again pair it with the 2 B's, RB1 and RB2. Then we're going to do the same for the male parent. Notice that these are all lowercase r's, so we've got R, and our first allele for beak is a capital B. We have lowercase r with the lowercase b for the second allele, which we'll call it 2. And then our second allele is also an R, so we've got an R again, a capital B, an R, and a lowercase b. The second step of this process then is to simply put everything, carry it forward into the boxes. So these are, of course, the gametes up here and down here from the 2 parents, and the filled in squares below in our 16 square grid will be the progeny that are produced. So we've got now capital R and a little r coming from here, and a capital B, capital B. And we're going to fill in the rest of this. Capital R, little r, capital B, capital B. R, R, B, B. Well, let's look at that Punnett square all filled out now. And we can see I've color-coded a few of these so that you could keep track of where progeny, shown here, we're getting their traits. These are the progeny. Getting traits from either mom or dad. And the first thing that we want to look at then is how successful have we been at getting some purple-breasted finches. So we're looking in that case for homozygous RR, and we've got that here, 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 here. So we've got 8 out of 16. So that's a nice 50%. And now we can also go back and look at another characteristic, and that is we were interested in a white beak. And we were pretty lucky in this case because that's going to be dominant. So we just need to look for one copy of B in the genotype, and it looks like every one of our finches, we've got 16 out of 16, which is 100%, or the probability of 1 that you're going to get that particular genotype and phenotype. So next we're going to look at another way that we could calculate this without doing a Punnett square. So I want to just emphasize here that we've got 50% were purple-breasted, 100% were white beaks, but we were looking for birds that have the combination of a purple breast and a white beak, so we ultimately have 50% there because we're looking for those two characteristics. The other half of the birds that we get out of this pairing are going to have a blue breast. Well, calculating the probability is pretty straightforward. And we're going to break it down into two parts because the probability of getting both of these characteristics, white-beaked and a purple breast, is going to be the combined factor of either white-beaked or purple-breasted alone. So we can break that down easily. We'll look first at the breast characteristics. So we've got our female here, R, capital R, little r, and here is our male parent who is got the purple-breasted phenotype being homozygous for the lowercase r. So we know that the offspring will carry these alleles, R, or the gametes, and RR, capital R, and little r again. So if we look at this, the probability of having a purple breast is 2 out of 4. That's 50%. And it's exactly what we calculated previously when we had the larger Punnett square. But let's look at the other genotype and phenotype that we're looking at, and that was looking at beak characteristics. So we've got our female up here is capital B, and here's our male parent, and he is capital B, lowercase b. The progeny of these two crosses, or this cross, would be capital B, capital B, capital B, capital B, capital B, lowercase b, and capital B, lowercase. Again, we look at the progeny and see that all of them have at least one copy of the dominant gene. So we have 100% with a white beak. And if we multiply those two to find out how many white-beaked purple-breasted finches that we are going to get out of this cross, again it's 50%. So this is a mathematical way to break down a more complex Punnett square.